A very fast follow to the idea of inheritance is an advanced concept, I'll call it, of an abstract class. Now, abstract classes are not required. You don't have to ever use them, but in many cases, they're very, very appropriate to be used, and they actually make a lot of sense in most inheritance hierarchies. So the idea of an abstract class is defining that conceptual parent. So in this case, we're going to start with this idea of a power plug. So we have an outlet, and I want to get something from a power plug. Now, abstractly, what I know I get from a power plug is I get voltage and current, which gives me some wattage, and which get power. That's wattage is a measure of power. Where does that power come from, though? Well, it comes from the electric grid, conceptually, right? But there's so many different ways that we generate electricity in the electric grid. We want electricity, but how we generate is really important. So the idea of an abstract class is we're going to gather this idea of I can get electricity from solar energy or coal energy or nuclear energy or natural gas energy or wind energy or some batteries out there. And so but I have this idea of an electric generator. I don't know how it generates electricity. I don't necessarily care electricity. It could be a tank full of electric eels going off every so often. But the point is, it has some sort of voltage as either AC or DC. It has some sort of wattage that's associated with it, and I want to be able to turn it on when I want to. So the abstract class is important because the concept of having power that comes to my socket is really important. But at the same time, I can't just simply say socket, turn on, right? I have to have something more practical to deliver my electricity. For the most part, we again go to an electric grid, which is a mix of all these things. But if that electric grid goes down, some people have backup generators, or some people have battery backups, or something like that, that will give them power. And but you have to instantiate something specific to get power. I can't just abstractly ask for power. So the role of an abstract class is to define a concept without actually defining an implementation. So for example, I could say, bring me food. And everybody, when I said bring me food, knows exactly what I mean. And everybody who's listening to this, if I said bring me food, would bring me something probably a little bit different. Something that's available to you, that's from your cultural background, that is maybe something you prefer. So I might get pizza, or I might get sushi, or I might get tacos, or I might get chips, or green beans, or broccoli, or Brussels sprouts. I mean, it depends on where you're coming from. So the purpose of an abstract class is to allow you to define attributes of the thing and even define behaviors by writing methods for the thing without actually creating an instance of that. So when I say food, or if I say electricity, it has properties, it has behaviors. Food has calories, food has nutrients. We don't know the amounts of them. It's abstract, and it could also have other interactions with my body. If I'm eating asparagus and I have the right DNA, maybe my pee smells funny. But that's the idea of that specificity. So I'm going to generalize the concept of food, and I have some specific stuff later on. The role then of an abstract class is to act as a placeholder for that need. I need power. I need food. And it's a point of replaceability. I might get my power from the grid, which could be coal-fired plants, or I can switch that over to wind and nobody would know any better. Or I can go to my backup generator when that's down and my house keeps running. So the other point of abstract class is the grouping mechanism. So again, I have a bunch of food. I can put my food in my refrigerator. I can put my food in my pantry. I can have a bunch of them out there that can be interchangeable towards feeding me, giving me nutrition, but also is a way of grouping it. I don't put my batteries in my refrigerator. I put food in my refrigerator. The refrigerator is a grouping mechanism for food. So abstract classes really serve a number of interesting methods without having to get very specific in its implementation. So abstract classes lead to this notion of what's called an abstract method. On its own, an abstract class, can define behaviors and can define variables. And if that's the case, why make it abstract? Well, the reason why I make it abstract is there's still something missing. And what's missing optionally, not required, can be additional methods that I know it needs to do, but I don't know how it does it yet. So for example, that generator plant, I could have something to say generate power, and I know that it has to do it, but I don't know how it's going to do it. It could be burning some fossil fuel. It could be putting it out in the sun or the wind. It could be somebody sitting on a bicycle and pedaling like mad. All those ways are ways of generating power. But I need to define the ability without actually knowing how somebody will accomplish it at the moment. It's again, it's a placeholder for ability that might be something I don't know how to do, we'll never know how to do, and you define it. Or it could be some sort of customization, like our paint by numbers here. The parent class might give you the whole picture of what it's going to look like, and then ask you to fill in the blanks of what's going on. So, for example, I could have an abstract class that knows how to send emails. It can connect to the internet and connect to a SMTP server, and it can send an email for you. And it might have the child class specify the subject, the recipient, and the body of the email. And so if I want to send emails to my program, I extend out the email abstract class and then say send email from the abstract class, and the class says, okay, well, who is I'm sending to, what's the subject, and what content do you want to give it? So that's a really powerful and flexible mechanism that abstract methods provide by allowing you to create frameworks or networks of things that can be specified later on. The other side of this that you might have caught before, you might not have, is the idea of members that are shared within the class but not necessarily visible to everybody else. So a protected member is visible to the parent class and usable by the parent class and any class that extends that class, any child class of that. And that's either an attribute or an operation or a method that can be used by the child class. And I can even define abstract child methods that are only used within the hierarchy. They can only be used by the parent and the child classes. So the role of this is to have data that is visible to the parent class and the children, but not the rest of the world. So if the parent class defines something as private, it remains private to that parent. So again, that email server might not let the child class see the password for the SMTP server to log in, but it can share, you know, the calls to getting the recipient list or store the recipient list right now. Maybe every email has a recipient, so maybe the child doesn't have to define it, but they could see the recipient list, and maybe they can customize the body of the email based off the recipient list or something like that. So the child then, when it inherits something from the parent, it actually has the option to make those things public. So if I have a method that I'm implementing from my parent, I can make it public and visible to everybody and share that information, but I don't have to. What I can't do is I can't have less accessibility. I can't have things that are public from the parent suddenly become private because the child decides it's so. I can't change that contract with the world to do less than what my parent does. So the concept of an abstract class is really not any different than any parent class, but the biggest thing is it acts as a placeholder. I can't create instances of it. I can't say, I want food. Ginny, bring me food. I have to ask something more specific depending on the context. Again, context matters here. If I want to eat food, I need to ask for, pizza or tacos or something very specific. If I want to sell food on a website, I certainly can create a class that is food, and it doesn't have to be abstract, right? Not every concept has to be abstract, but it does in certain hierarchies and certain uses. But the idea is to capture concepts that other parts of the code can refine further. If there's no refining needed, you don't need an abstract class. But if there is, it's super useful. The point being is it enhances the extensibility of code, the ability to add new things later on. So if you're creating a video game and you want to create a bad guy, NPC, something like that character in the video game, you can create an abstract class to represent what a character in your game looks like and allow that additional characters to be created in the future. And so I know what all characters must do, and I know where I'm allowed to customize characters, and I can create different types of bad guys or NPCs or you know whatever I want to in the future. Again, not everybody loves video games, but it's a good example in this case. I haven't done a video game example in a while. but that placeholder gives you a way of telling people in the future, this is how to make our software do more in the plan that we have without having to rewrite everything. It's a really powerful mechanism. So something to think about as you're doing design, but again, don't fall in love with this. Just because we talk about abstract classes, you're not going to see, at first you'll see abstract classes everywhere, but they're not super, super common. Less than 10% I would say of classes are ever, probably less than 5% of classes are ever abstract classes, but they are super powerful when they appear. So find them and use them wisely.